So again, section 6, we're doing an intro to object-oriented programming. It'll lead into section 7, which is object-oriented programming continued, all right? Note that I won't go through all of section 6 probably today. I probably will continue it for when we do Tuesday, and we'll go into section 7. So just know object-oriented programming, I think I mentioned this earlier, is that computer scientists, if you would go into a 4-year degree for computer science, you're going to spend like probably a good year just hammering in the concepts of object-oriented programming and all the different nuances and stuff. We're doing it in 2 sections instead of just 1 section. So yay, right? So just kind of be aware that like it is a big concept, and it's not, you know, if you have experience, you will have an easier time. But if you don't, just know that it does take some time just to get used to and really wrap your head around it. Okay, but I'm gonna give you guys a quick overview of like what well, I'll call it OOP now, right? What OOP is, and then we'll actually see some code of like how this works, right? So first thing is like, what is object-oriented programming? And so basically all you have to think about it is that it's a way of structuring programs. So we see a few programs, for example, procedural languages, functional languages, and object-oriented programming. Some of this is like, there's some gray area where you can do a little bit of both. Some programs are specifically only functional programming languages. For example, Haskell for functional programming, you cannot do object-oriented programming in there, not in the classic sense. In fact, Haskell is a really interesting language, is a pure functional programming language, which means there's not even variables, which is kind of a weird thing to kind of wrap your head around since we use variables all the time. Procedural, this is kind of like the classic programming of like C, you know, Fortran. Think of like goto, like when you like go to a line, that's kind of like what procedural programming is. This is much more old school. You can do much more efficiencies on this, but to be honest, most modern languages, we're not doing this. And then we have object-oriented programming, which are basically, they're much more focused on object-oriented. For example, Java is built almost completely out of object-oriented programming. Everything's an object in this case. Python, we can kind of get a little bit mix of both. JavaScript, same thing. JavaScript can be argued to say it's actually a very function first. So just know that there's different structures. Now, what's kind of nice is that it's not necessary to have OOP. Like you can do the same stuff without OOP. It just helps you make things easier. Just like a function in a lot of ways, you can like never do functions and you can live a horrible programmer's life, but you could do it, right? Like you could always perform the same thing over and over again and copy and paste every single time. But of course that's really lame and like takes a long time. OOP is the same way, except it's a little more advanced. It's beyond just functions, okay? So we have this concept of objects and classes. And so one thing I use this metaphor, which the curriculum doesn't, but it makes sense to me, is that it's kind of like making a mold or a blueprint. So you can kind of think that a class and an object, and again, the curriculum kind of talks about this, and this is my way of going through it, but basically a class is kind of like the blueprint itself, and the object is the object itself. So for example, you might have the idea, the concept, the blueprint, the mold of this thing called the class. So you can think of it like, I like to think of a mold that you like pour plastic into, okay? The mold itself is the class. That's what makes the object, right? The mold itself isn't the object. The blueprint's not the actual object, but we use this mold or blueprint to actually create an object. And once we have an object, it's like a thing, right? It's like a thing that I can play around with, it. I can hit, I can break it, I can tear it apart, okay? That's the concept of what an object is, okay? And so here you can kind of think of like this more on the programming side, is that a class would be like saying, oh, it is a car. And then we can take the concept of a car, the mold of a car, and make specific objects. For example, oh, here's a Mercedes, here's a BMW, here's an Audi. You can also make like 50,000 Audis that are all identical, but they're all their own object, right? So this is actually one thing I kind of compare is like, you can also have like the class of a person, right? And you can even have a class of like a specific person. For example, you can think of like your DNA, I guess, like as a person, right? Like saying, oh, this is the instructions of how to make a person. For example, twins would have the same DNA, right? But even though they're built from the same, you know, quote unquote class, obviously I've stretched, but like they're built from the same class, they're not literally the same person, right? Like if I poked one twin, the other twin doesn't feel it. I mean, hopefully not, right? But like the idea is like, you know, this person is something different. They're a different object. Just like if I make 50,000 copies of an Audi, if I basically smash one Audi's windshield, not all of the Audi's windshields are broken. If I mess up the design, the class, if I put a flaw within this class and then make 1,000 copies from that class, then all of those objects that I made will now have that flaw. Okay, so that's the distinction there. Okay, so it's a little subtle, but you'll see this again where we define a class and then instantiate an object. Okay, so attributes of a class give attributes to an object, which is not the best term, but basically the idea here is that what we have in the mold, what we have in the blueprint, will tell us properties of this object itself. Okay, so this kind of gives you a reason like why you might want to think like, you know, instead of trying to build the same thing over and over again, we can now use this class to basically make a mold and say, all right, make this object, make this object, make this object. Okay, so again, a few reasons why we talk about OOP, especially for data science, but one is that everyone's doing it. Almost everything is written in the modern language right now is written in some form of OOP. For example, even just using the fact that pandas is actually an object. It's actually defined with OOP. But basically almost every language that's modern right now supports some form of object-oriented programming. So just kind of know that that's what's going on. For example, Java's just there. So just know that whatever code you're going to come across, it's probably going to have OOP within it. Okay. Let's see here. A method, a pun. All right, a method to organize your code. So again, it's not that you need to have OOP. It's just kind of like a philosophy of how we do programming. So the idea is that there are things that exist, and these are our objects, and we can make, you know, use the concept of these objects from a class to make these things. Okay, and just makes it easier to break down. So then we say, oh, what is an object? It's like, well, it can be, you know, anything. It can be a car, it could be a robot, it could be a person, it could be a data frame, it can be, you know, a series, it can be a protocol, like whatever is a thing can be made an object. That's the idea here. Okay, and again, it's flexible in that same way that I can create an object. It's kind of like you do like modifications. Like if people are like really into cars, you put a new stereo system and all that stuff. You can make a class and like make it very specific, you know, like make 1,000 copies or 100,000 copies of this specific car, and then take that individual car and make modifications to that car. Okay, so that's makes it really flexible in that way. Cool. Any questions on this overall concept of like, you know, what classes are versus an object? Cool. All right. So now we're actually going to talk about actually using some of this code. So again, I want to keep emphasizing as a class, you should think of it as a blueprint. I think of it as like a mold, like, you know, you're pouring in plastic into this mold. And again, the mold is completely separate from the object, right? It's not like it's the object. You're just making a new thing from the mold. Okay. We call it instance, like you're creating, we'll call it instantiate. You're making an instance of your class. An instance is basically just an object, okay? So, and again, it's an individual. If you poke a clone, or if you poke like a twin, the other twin doesn't feel it, right? So cool. All right, so here's some code. So don't freak out, right? But we have our code right here, and I'm gonna make this class, and you'll see that's very similar structure to like how we do a function. We use the term here class, just like we did like DEF for a function. We have a class called a robot. Okay, and I'm just going to basically put this pass in here and basically just saying, hey, make a class, don't do anything with it. So you can kind of think of it like a blank slate. That's what's going on here. Okay, so I run this now, and now I have this thing called robot. And note that in Python, we classically capitalize classes. That way we can distinguish it. It's not required to have a capital, it's just convention. That way we can see a function, say, ah, that must be a class, and we can immediately go from there. Okay. So we have this class called robot, and now I can actually call this robot. And note that it's very similar to a function, right? It's kind of similar to how we would call a function through here. So I'm assigning this my robot equals robot, and this creates what we call an object. It instantiates an object, right? It's creating like a stamp. You're pouring in the plastic into the mold called robot. So now we have something called my robot. In this case, I can start giving it name, or you can give it properties. So I made this blank slate, and now I'm going, all right, I'm going to give it, and these are just random. I could have put whatever I wanted in here. I'm going to say, okay, my robot is going to have a dot name. We've seen these dots before, right? So we're basically giving the property saying dot name. So, okay, you're going to have this property called dot name, and we're going to call you Wally. We're going to have a dot height, 100 centimeters. I just put 100 there. Okay. And now I'm going to make a new object, right? So completely separate from Wally, but from the same mold, right? Your robot. In this case, I'm going to name it Rob and a height of 200 centimeters. Okay. So this is me instantiating the object, right? So now I made these robots called Wally and Rob, and they're ready to rule the world, right? So now I can actually see, it's like, all right, it saves as information, my robot.name, my robot.height, okay, your robot.name, your robot.height. So we should see Wally 100 and Rob 200, okay? So again, this is me creating these robots, okay? So any questions so far of what I just showed? Okay, thumbs up, thumbs down, sideways. Okay, cool. I'm seeing some sideways right here, but mostly thumbs up. Okay, yeah, again, main thing you should think about is that I made this function. I made this class. It's kind of like a function. I use that class to create my instantiate. I poured that mold into the plastic. That's what's going on here. I'm pouring the mold into the plastic, and I create my thing called my robot. And then with my robot, I give it a name. I slap on like a label. It says, hey, your name is Wally. And say, hey, your height is 100 centimeters. Okay, and then I can actually print this out. So anyone got to guess what will happen if I try to print out my robot.purpose? Does it have a purpose yet? It has no purpose. It has no clue why it's alive, right? And it gives an attribute. It's so sad. So we need to give it a purpose, right? So again, we have to define everything on here. So you can imagine it's like, okay, cool. We can actually keep these. It's kind of like an advanced variable if you think of it, right? Like, cool, I gave it a Wally 100. I could give it whatever I want. But because I didn't give it a purpose, it didn't know what its purpose is. Okay, so now we can actually start improving on our robot. And since it's like, you know what, I want my class, like my class of robots, I want my robots all to have the purpose to love humans. Okay, and because we all just want to, you know, that's the whole point of having robots, right? Just care for us, right? So we can actually create all robots to have this purpose called to love humans, right? So that means every robot I make will create now, will have a purpose called to love humans. Okay. So I run this right here, same exact thing, right? I had before. I'm giving it a name, I'm giving it a height, same thing for Rob, okay? And now what's cool, it's like I can ask it, all right, print, what is your purpose? And now I can say my robot.purpose. And remember, I never gave any of them explicitly telling them, like, hey, your purpose is to do something or whatever it is, right? I can say, all right, I can use that from my original robot mold, my original robot class. And now every robot will have to love humans, okay? So for example, if I put in your robot, you'll see it'll also love humans, okay? Cool. So now I have a little example here where I have a little special robot called Evil Robot. You can kind of see where this is going, okay? I create my new robot, I make a new object, okay? I name it Bender, and you'll notice that I hijack this purpose, and I'm telling its purpose to kill all humans, okay? So obviously not the best robot here, okay? But basically I'm overriding the robot, this dot purpose to kill all humans. So now if I say, all right, what is your name and your purpose? You can now give it its name, it's evrobot.name, and its purpose, whatever its purpose is. And you can see his name is Bender and it's to kill all humans. So you can see now I can reprogram like, you know, these objects. And this is the same way I can talk about like when we have a new car, we can take that car and modify that car and like give it a sweet new stereo system. In this case, I took my robot and made it evil essentially, right? I gave it a different purpose. So this is the way you can kind of like have a mold, but then later on change it into something else. Okay. Any questions on how this worked over here? No questions? Cool. So far, so good. All right, cool. So now let's see here. Instantiating an object using our mold. I don't actually remember what we did, but we created a class over here. So let's see, example code. Okay, cool. So I'm just using the same exact thing. My robot, my 100. Okay, oh, so this is some of the reasons I did this to show you why we would want to do this. Like, okay, like cool, we made these things, but like, why is this useful? It's like, well, now what happens is that we can actually give properties to these objects and then use that comparison. So for example, if I just want to know who's the tallest robot, right? Normally, if you think like, if I had to structure this, I had to put it like some list or some dictionary or some kind of weird structure just to carry all this information. So in this case, I just want to know who the tallest robot is. So I say, all right, tall robot, or tall bot is going to be a robot, my robot, if my robot's height is greater than your robot's height. So basically, if my robot is taller than your robot, then mine's the tall bot, right? I'm just going to call it, that's the tall bot. And if it's not, then your robot's taller. Okay, in this case, Rob should be taller, right? So we won't just save the name Rob, we'll save the actual object into tallbot. Okay, so now whenever I call tallbot.name, it will give me whoever is the tallest robot. In this case, it will be Rob. And then tallbot.height was saved over here. Well, tallbot is just Rob in this case, right? So it'll give me a height of 200. So you can see, it gives me this. Okay, cool. And of course, if I did it like less than, right? Obviously, then it will be Wally. Okay. Any questions on this? Okay. So what's nice about, again, what's nice about this is if I put in, like, for example, a little extra thing, let's say, I don't know, let's say color equals, you know, yellow. And I do like your robot dot color is gray. Okay. Now I can actually put in, for example, gray here. And I'll make it taller. So I'll grab whoever's the tallest robot, okay, and then I can start, you know, I can actually do things with it. For example, I'll say, okay, cool. That means you're, oops, I didn't run this guy. Oh, he doesn't have that property, gray. He has property color. So you see gray pops up here. So this way I can kind of organize my robot. I don't have to like search for that specific stuff. I just know now, like, oh, this is my tall robot. Okay. Any questions on this? Cool. So far, so good. All right. So let's see here. So this is a little interesting part. It's like, now that we have these two objects, just like how I can't poke a twin and the twin feels it, right? You know, 50 miles away. These are all its own objects, even though they created their, what's it called? They were created from the same class, the same mold. They exist in different spaces, right? In this case, we call it like a memory space, right? But like you can imagine, it's like, oh, I made my robot, you know, Wally, and your robot called Rob, and they exist in two different spaces. And so we call this like in memory. So you can actually, if you try printing this out, you can actually see these things right here. These are actually its memory spaces. This is actually where it sits in memory in the computers. So it's like, you know, we kind of talk about things like digital being like, oh, it's all like, you know, in the ether of, you know, whatever it is, right? But they actually sit in a spot in the computer's memory. Again, this is more advanced than you really have to talk about, but just know that this right here by default is just saying, hey, this main.robot, okay, this object is at this memory space. It's somewhere in space. And you can see that this memory space is not the same place, right? It's a different robot, okay? So now I can actually start asking a question. Say, for example, if I say my robot is equal to your robot, okay, should it be equal to each other? No, right? Because it's a different robot. It shouldn't be the same. And just know that this is the same thing. I'm asking, is it the same robot? So you can see like, okay, these, for example, should just give false, right? Okay, but this guy right here, my robot equals my robot. Does my robot equal my robot? Yeah, right? It's the same robot. So you can see it'll get false, false, true. Okay, simple enough. So now I have a generic robot 0, generic robot 1. Remember, I haven't changed anything about this. So the only thing that gets assigned in this case is that generic robot 0 purpose is to love all humans. And then generic robot 1 is to love all humans, right? It's essentially like they look identical to each other, right? So I want to see, is generic robot the same as generic robot 1? And is generic robot 0 the same as generic robot 1? So quick question. So give me like, you know, thumbs up if you think they're going to be the same. Give me thumbs down like they're not going to give me the same. You're just going to give us false. Cool. All right, cool. I think everyone got that thumbs down, which makes sense. They shouldn't be the same robot, right? Even though they have the same exact, you know, properties, they both love humans, they're both individuals. They're their own individual snowflake robot, even though they're called generic robot 0, okay? So again, they're just individuals, completely different objects. So you can see right here, I even print out their memory space. You can see their memory, they exist in a different space in memory, okay? So this one's a little interesting now. So now I have same robot equals generic robot. Is generic robot the same as same robot? So should this give me true or false? So thumbs up if you think it should give me true. Thumbs down if you think it should give me false. It's a little tricky, huh? Okay, so I see some thumbs up. I see some questionable thumbs up. Follow the crowd, right? Like just, well, at least everyone else did it, right? And it turns out, yes, it's true, right? So basically this is a little different from a twin. Like I'm basically saying, all right, this variable, like just like that, like tall robot. I'm like, it's me essentially pointing. It's like, hey, that is my robot. This is me pointing at that robot. So no matter if you point to this robot, or for example, if I put like, you know, let's say like just bot equals generic robot 0, okay? They're pointing to the same robot. So those would always give me true. So, okay. So that's a little difference right here. But that makes it really useful because now we can say, we can point to a robot and say, all right, this robot right here, this is the tall robot, okay? And everyone knows it's a tall robot and we can reference it now and do all the interesting stuff on this little pointer, okay? So again, a couple other things like I just showed you like, oh, same robot, they have the same memory spaces, okay? Which means it's the same robot, okay? And then same robot dot name. So this is an interesting one. If I took same robot, which remember, I was just pointing to generic robot 0, and I say dot name. We never gave it a name, right? And we never gave generic robot a name. And I say, all right, same robot is equal to 001, okay? What will same robot dot name give me? What will generic robot dot name give me? Will we get an error or should we get something else? Anyone got an idea? That's tricky, right? All right, so the nice thing about programming, we can just go and find out. It's the same, right? So basically it comes down to, because we're pointing at it, it's like, hey, when I assign same robot dot name, I'm saying, hey, this robot right here, this robot has this name. And someone, I don't know, like the computer gods, right? Say, all right, this robot has this name 0001, okay? So that means no matter how I reference this will always give me that say, oh, this robot has 001. And in fact, kind of following it up then, I kind of added this in right now. If I do bot.name, will this give me an error or will this give me 0001? Because remember this bot was assigned up here.
I think it should give 001.
Okay, cool. So thank you, Rudy. And it does, right? Because again, it's just pointing, it's just another person pointing at the same robot. Okay. Cool. So there, you guys already learned a lot of advanced programming stuff that we would take like a whole like month long to talk about, like how, you know, namespaces and blah, 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 blah. So cool. Awesome. You guys all passed with flying colors. So last part here, I only have a few minutes, but I think I'm going to go ahead and start this and we'll probably review a little bit for next time. We can do something more than just give it just a dot name or, you know, get it just purpose. We can actually make it do things. We can give it functions. So the way I kind of think of it is like when we talk about a person, for example, like when we create the concept, the class, the mold of a person, it has certain functions. For example, a person can breathe, you know, sure, a person also has a name, you know, but also it's like, oh, we can tell the person to breathe. We can tell the person to spit. We can tell the person to like run into a wall. You know, we can tell a person has functions. A person has certain things they can do. And for an object, we use the terminology called methods. Basically, a method is a special kind of like a function. It's a function that's tied to that object, okay? So we'll see a little bit more of this. But kind of show you a little bit. We had some variables in here. So you can see my robot is getting much more complicated. Before, all we had as its purpose was to love, right? Or to love all humans. And we can see here, now we're adding some extra functionality in here. We have our name right here, so our default's to none. A material, metal. Is it electric? True, okay. Number of arms, 2. So note that whenever I create my robot now, this now has I'll scroll up a little bit. This now has the mold, the defaults is all of these things. The name, which in this case is just none, but I have a material, I have it is electric, and I have number of arms. So now if I just run this right here, and now create a new mold called, you know, robot with all these extra properties, okay, essentially your variables, okay, and now I can say Wally, right, and I just gave it a variable name Wally equals robot. Note that I didn't change the name, I just set the variable to Wally, okay. So now right here, all I did was just pour the plastic into the mold. I now have my object called, you know, my object, quote unquote, Wally, and now it has a name, material, is electric, number of arms. In this case, the name's gonna be none, but you can see here, it now has all these properties in here. And it's because it's Wally, right? Quick quiz. If I change this to like, you know, if I did like, let's say robot B equals robot. Okay, and I did this guy right here. Would B be the same as Wally? Is B equal to Wally? Oh, good, I see some handshakes, good, all right. Good pop quiz, everyone. You all pass. Okay. So anyway, I made this more complicated robot. And now I can actually say, all right, cool, that's nice. Like, he's metal, he's electric, got 2 arms, but I want to give him a name. I want to give him an identity. I want to change him up a little bit. So now I'm customizing him. So I say, all right, Wally, that robot, your name is now Wally, okay? And I say, all right, and I also want to add a new attribute, a new property. I'm saying, all right, I want to say that you have solar power. So I'm basically modifying my, little robot and say, all right, I'm going to slap on a label called Wally for you. And also I'm going to give you basically let you know that you have solar power. I'm going to give you solar power. So say equal to true. So again, this never existed before, but I never stopped this before. So now I can actually perform all these things, and you'll see now the same exact properties before, but in this case, he has Wally, he's still metal, he's still electric, he's got 2 arms, and he's also solar, okay? So this allows us, again, to just add more features onto him. And I could add as many as I want to, even though I didn't have it in the original mold, okay? Cool. Any questions so far? Thumbs up, thumbs down, sideways. Okay.
So if I have a question. So if I change name from none to Rob, for example, so Wally's name will change as well, right?
Let's try it, right? So if I change this right here, so now I ran this part. So now any robot I make now will have Rob. And is your question if I run this now, let's say I get rid of this Wally name, right? Are you asking, like, right now, Wally's already been created. I create a new mold, and are you asking that will this robot
will Wally's name change?
Okay.
Yeah.
Yeah, so let's try it out, right? So first of all, let's do some predictions. Thumbs up if you think his name will change to Rob. Thumbs down if you think his name will stay to Wally. So thumbs down for Wally, thumbs up for Rob. Forgot which one's which. All right, what's this one again?
It's Rob.
Okay, Rob. So for Rob, okay, I see some people saying Rob, some people saying Wally. Okay, so let's see. So we run this, and you can see it's still Wally, okay? And the reason why is because, remember, just because in the factory we made some updates. For example, let's say some car gets made at a factory, right? It gets made with, I don't know, like some flaw, like, oh, like the doors don't close or whatever, or like, oh, the car is blue, right? And it gets put out there, and you have a blue car now. And then the factory says, oh, wait, no, we want it to be yellow. And the factory changes how they do the production and make everything yellow. Well, all the new cars will now be yellow. But of course, your car is still going to be blue. It's not going to magically change, right? And that's kind of like the same concept.
So if I make a new robot, his name will be Rob by default, right?
Mm-hmm. And say, let's say a new robot, I'll just call him X robot. And let's just do, what's it, X dot name. We can see his name is, okay. So cool, yeah. So again, it's just like if we make new robots from our new class, then we'll get new properties or whatever the properties were from the class, okay. Of course, if we change the mold and we already made the robot, we'll keep it out. Who had a question?
Me. So can we print all the properties from all robots or the current robot molds?
I gotta be honest, I don't actually know if that's a built-in function that we can do. And one of the reasons why I'd probably say there's not a built-in function is just because there's so many things. I think actually, that doesn't let me do it. I think there might actually be something where we can print out all the properties. I personally don't know it. We could like search for it right now, but yeah, that's I never thought about that one, but you might be able to. Might have to. I'm gonna look that up and get back to you guys because that's something that's interesting. But generally, you don't necessarily. What's nice about object-oriented programming is that you don't need to necessarily know all the properties for a for an object, because some of these, for example, we'll see later on in let's see here. They're next for section 7. We'll talk about something called private variables. And some of those variables, it's not that they're actually private. In Java, for example, they're actual private variables that you cannot access. In Python, everything is public, meaning that if you know what the name of the variable is, you can go find it. But there's, by convention, we have these things kind of quote unquote private variables. That way a user, a programmer, when you're using your stuff, you don't actually like break the system. So for example, when you guys are using pandas is actually, when we use a data frame, if you remember, if we do like, import pandas as PD, we can do PD dot capital data frame, right? And that's because data frame is an object. We can actually do that. And so we don't want to accidentally break the attributes and break the functionality of the actual class or like of that thing. Now, there's some ways we can access certain things, but again, we haven't really talked about that. So I guess, yeah, I'm not quite sure if you can actually do that, but in general, you probably wouldn't do it. Okay, but good question. All right, any other questions you guys have? Okay, cool. So I'm thinking, all right, we have a few more minutes, so I think we'll see what we can do this. Otherwise, we'll continue it for next class. But our next part is our function. So we've seen right now, we've had, basically variables, essentially attributes of their class, okay, which give the object properties, right? So by us having this attribute for name and material, it now has the property material. Now, we can still change it up and everything like that. We can customize, we can, pimp our ride Wally, right? We can do whatever we want with him. But of course, is that these are the defaults that come through. So we can also do the same thing with like functions. In this case, we call them methods when they're tied to a object. So class methods first. So when we have a class method, basically you can think of it as being tied directly to the mold, which is this one's a little hard for the metaphor, to be honest, but you can think of like when we have this class function, it belongs to the mold. And we'll see what this means. So for example, you can see I have a robot, a law of robotics. So you can see like, oh, every robot's gonna have this, what's it called? This property, law of robotics, which is just a list, right? And then I also have, our function print laws. And then I'll say basically for this, it'll print each law, okay? And then you can see print n law, it'll print a certain law, the first law, the second law, the third law, okay? So just know that that's what these functions are doing. But the main thing is you should notice that I actually defined a function within a class, okay? So I run this guy right here. And now, for example, I now have these things that are tied directly to the mold. So in this case, I can actually, so notice that I didn't instantiate, I didn't create a robot right now, but the mold itself holds this property, okay? So for example, I can do robot.law of robotics, and this will give me the list of the law of robotics, okay? And you can see this gives me all of this stuff right here, okay? So I can do something similar. For example, I can call a function, right, directly from that class, from my mold, right? And you can see it'll print out all of these things. For example, if I just want the second law, same idea, I can print this part, okay? Which is cool. Like, I'm like, oh, cool, I have a mold now that can hold all this information. But I mean, it's like, okay, I probably want it built into our actual Wally robot, our little object robot. So if I do this now, so does Wally have these functions? So I can create our robot, right? Wally equals robot, okay, just like before. And Wally.law of robotics, which you guys have seen before, that should give us a list of the laws, right? Because now our robot has it. And it's like, okay, cool, that all makes sense so far. I do, all right, Wally.print laws. Ooh, what? You can see here, it gives me an error. It says print laws takes 0 positions, 0 arguments given, but 1 was given. Basically what it comes down to is that this print laws is actually directly tied onto the class itself. Basically, it's tied to the mold, which this is where our analogy kind of breaks down of saying it's a blueprint or mold. It's a little different, but basically the idea here is that this function is only being used on this class robot. That's why we're able to call it here, but if we put Wally in here, it doesn't run, okay? So we need to somehow tie it to Wally, our object itself, right? And this is where something called self comes in. All right, so you can think of like when we use our word self, it's tying to the robot. It's tying to my object itself, okay? So you'll see it's very similar like we had before. I still have my properties here, okay? My name, material is electric. And I have my function here, but you notice I got this special kind of thing right here, this self attribute, okay? And you'll see I have this self.name. And you can see, for example, add numbers, I have self, number 1, 0, number 1. We'll focus mostly on this one for right now. We'll talk about this maybe next time. But the main thing I should say is that this self basically tells the functions like, hey, this function is not just any old function. This function belongs to you, little object, little robot. you have this function. You can do this thing. Not just my class, not the class, the mold, but this belongs to you. So that's what this self is doing. And basically it says, all right, now I have the self, I can now call, say, hey, this object is going to have a property called .name. So now I can actually use that .name within here. Versus like right here, if you notice it like in the very beginning, if I wanted to print something like, speak and like wanted to say, oh, say your name, it doesn't really have a direct way to do that, saying, oh, that specific object is going to call its name. That's what the self does. So self is kind of like giving it like identity, essentially tying that function directly to the object. So now if I run this, I'll get my robot, and I'll split this up so it's a little easier for us to read. So we have a robot. I'm going to print out his name, his electric, number of hours, just like before. Everything's all good. And now I'm going to comment this out because we want to focus on .speak. Now I'm going to say, hey, Wally, okay, my little Wally robot, go ahead and speak. And remember from this function now, it now says, oh, I have a self. I'm going to basically say, all right, self, myself, what's my name? And basically we'll say, oh, I am, in this case, will be Wally, right? Or, oh, in this case, we'll say none because he doesn't have a name yet, right? So I do Wally.speak. I can see I am none, all right? So now we can actually give him a name, say, all right, Wally.name equals Wally. And instead of just having none like before, we can actually make sure he says his actual name. I am Wally, okay? So this is how we can actually use our objects and tie the functionality built directly onto the object, okay? So this kind of gives an idea. And this is a little extra stuff that I kind of showed just to show you can redefine this function. It's a little harder to do, but in this case, I create a function with a lambda function and say, all right, go ahead and print out so it says Wally, right? And I do this part, and you can see I now define a new function. So now he will just say Wally, okay? So you can see right here, he'll just say Wally. But note that I also changed him to like Rob. He'll still say Wally because that's the function that's tied onto here. Okay, so I'm just showing that it's just another, it's essentially like another variable we can change parts. One thing I kind of skipped over was you could do this thing right here where you'll see that there's other parameters, and we'll see this a lot more for next section. But you'll see here, I still have that function that says, hey, this function, this belongs to you, little robot. This is your little function that you can do. You can do add numbers. And I also have extra parameters. So again, it's just like a regular function. I have itself, which basically gets tied to the robot, the object I create, a parameter called number0, num1, and I can say total equals num0 plus num1, and I can return that total. So now if I actually do something like, oops, so this, I can say, all right, robot, little robot Wally, go ahead and add the numbers, okay, 0 and 1, and you can see it returns 101. So this is how you can actually create functions that that belong to the actual object, but can still take in extra parameters and do extra things. And you probably have seen, like, you guys probably are seeing this right now. It's like, wait, I've seen this notation. You guys have seen this dot, a function and then passing in parameters. That's because it's literally built on the class. In this case, the object itself is Wally. This is the method that's tied to Wally, okay? And these are the parameters for that specific method, okay? Cool. All right, I know I kind of ran a little bit over. So this is becoming a theme now, isn't it? But are there any questions you guys have that I showed? Again, I kind of walked through this one pretty quickly, but hopefully you guys get the concept. Cool. All right, thumbs up, thumbs down, sideways. All right, cool. All right, I always like thumbs up, but I always wonder, I'm like, oh, that may I not explain it well enough? Like, did I not quite like make it too complicated? Which maybe like skipped over some stuff. But I think hopefully this is pretty good.